Now, this question is about a radar gun being pointed at an approaching car. So there is a police officer and he is pointing a radar gun at a car that is moving towards him. And it says there's a frequency change, and it gives you a formula for the frequency change, and then it says explain the reason for the frequency change. Now, the first thing you need to do is say that the reason for the frequency change is because there is a relative motion between the two. One of them, either the car or the police officer, is moving relative to the other one. So you can say there's a relative motion, or you can simply say that the frequency change is due to the Doppler effect. And then you need to say what that means, because you can notice that it's 3 marks, so you're not going to get 3 marks just for saying Doppler effect, so you can then say what that means, and it means something like the reflected waves are coming from an approaching source, so when the waves bounce off the car, they are reflected and the car becomes the source, so the reflected waves are coming from an approaching source, because this guy is going to receive them again. Or you can say the incident waves strike an approaching observer, so the rays from the radar gun strike the car, and the car is the observer in that case and is moving towards. And then finally you need to identify if it's an increased or a decreased frequency. Well, the car is moving towards the person, so the wavelengths are going to get squashed together, so the frequency is going to increase. So you need to say that finally, on this page, suggest why there is a factor of 2 in the frequency change equation. Well, you need to take into account, first of all, the car is the moving observer. So as the car is the moving observer, the radar approaches the car, and the car is moving towards the source, so the car is the moving observer. And then when they reflect, the car is now the moving source. So the Doppler effect occurs twice. Now, the second part of this question asks you to actually determine whether the speed of the car is below the maximum speed allowed. So is the car speeding or not? I've copied the information from the other page just so you can all see it in one place. So I've put that information up here, and they've even given us the equation that we need to use for this particular question. So all we need to do is we need to rearrange this. We want to find out the speed of the car, which is v. So we want to find out v, so we need to say that delta f over 2f multiplied by c equals v. That's just a rearrangement of that equation. And then we put our numbers in. So delta f is 9.5 times 10 to the 3 hertz. C is 3 times 10 to the 8 meters per second over 2f, which is 40 times 10 to the 9, gives you a velocity of 36 meters per second. And 36 is greater than 28, which is the maximum speed allowed, so car is speeding. Okay, the next part of this question asks us to put in some information to find out the distance between 2 aircraft when their images can just be resolved. Now, we know that when 2 images can just be resolved, the central maximum of one of them must just coincide with the first minimum. And because we're only dealing with a single radar receiver, we know that it's the equivalent of a single slit. So theta equals lambda over b. However, it's a circular radar receiver, so we need to multiply that by a factor of 1.22. So if you put your value for the wavelength, 2.5 times 10 to the minus 2, and your value for the slit width, if you like, which is the circular radar receiver, which is 9.3 meters, then you get a theta value of 3.28 times 10 to the minus 3. Now that is the angular separation, the minimum angular separation when we can resolve the two aircraft. So if we've got that angular separation, we know that if the angular separation between the two aircraft, that's aircraft 1, that's aircraft 2, that's 3.28 times 10 to the minus 3 radians, then we want to find out this distance here, which is the minimum distance between the two aircraft, which is x there. And we've got this distance here, 31 kilometers, and so we want to find out what x is. We've got this small angle here, and so because it's a small angle, we can do the small angle approximation. So theta equals x over 31. So 3.28 times 10 to the minus 3 times 31 equals x in kilometers. And x in kilometers is 0.1. So you can have 100 meters as your answer.